In healthcare, there is an obligation to use reliable measurement tools when assessing clients' functional capacity. The tools used must be ones that have been studied and are established in practice, meaning that evidence about their reliability has already accumulated. Considering the measurement's reliability, it is also essential that the tester uses the measurement tool correctly and with the appropriate target group.
When measuring functional capacity, different measurement types can be used. Quantitative measurement provides numerical results, such as degrees, length measures, or time. Semi-quantitative tools are often various rating scales or indices. In semi-quantitative instruments, results are expressed on an ordinal scale, but they are not exact numerical values. For example, muscle strength can be measured using the so-called Oxford scale from 1 to 5, but the measurement is based on the tester's estimation of the level of strength. Similarly, pain is often measured with a visual analog scale where different numbers describe the intensity of experienced pain. Qualitative measurement of functional capacity is, as the name suggests, qualitative. For instance, describing an activity such as walking or running verbally.
The two components of reliability are reliability and validity. Reliability refers to tools' ability to produce non-random results. For example, the extent to which the same tester or different testers obtain similar results under standardized conditions. Reliability is therefore divided into two sub-areas. 1. Intra-tester or intra-observer reliability, which is also called tester-specific reliability. 2. Inter-tester or inter-observer reliability, which is also called reliability between testers or observers.
Validity means the extent to which a measurement tool succeeds in measuring what it is intended to measure. Validity can be tested through the measurement tool's sensitivity and specificity, which can be also called discriminative ability. Sensitivity refers to how well the measurement tool identifies positive cases among those being observed. Specificity refers to how well the measurement tool can exclude negative cases from the observed group.
This picture shows three measurement tools with different properties. The measurement tool in the first picture is neither reliable nor valid because repeated measurements are random, and moreover, they do not measure what was intended. The tool in the second picture is reliable but not valid because repeated measurements are close to one another but do not measure what was intended. In the third picture, the results of repeated measurements are close to what was intended to be measured, so this instrument can be considered valid.
When selecting a measurement tool, information is needed about its reliability and validity, but also about its construct and responsiveness. The construct or conceptual model underlying a tool defines what the tool measures and for which target group it is designed. For example, a tool designed for adults may not be suitable for children, or a tool developed from a particular cultural background may be inappropriate for measurement in another culture. Responsiveness is the tool's ability to detect changes over time in the characteristics being examined. In other words, responsiveness refers to the tool's ability to detect change in a client's results when the results have genuinely changed, and correspondingly to distinguish those clients whose situation has not changed.
The reliability of tools can be evaluated using statistical methods. Reliability can be reported, for example, with the intra-class correlation coefficient, ICC value, or with Cohen's kappa method.
ICC provides a value between 0 and 1, and there are several formulas for calculating it. The closer the value is to 1, the more reliable the measurement tool is. For a tool intended for clinical use, the ICC should be at least 0.9, and for a tool used in research, at least 0.8.
The slide shows an example of using ICC to evaluate the reliability of a clinical measurement tool. Hip range of motion measurements obtained with a goniometer were compared with 3D movement analysis during the same situation. The results show the ICC values for these measurements. According to the results, measuring hip rotation range of motion with a goniometer is more reliable than measuring ankle dorsiflexion.
The slide shows an example of results from a study comparing the tester-specific reliability of the 3 different measurement tools in measuring range of motion in different joints. The results show variation in ICC values between the 3 tools and also variation between the joints measured.
Measurement errors can be divided into random and systematic errors. Random errors are difficult to identify and eliminate. Random errors occur in all measurements and can be reduced by repeating the measurement. Improving and refining the measurement tool and increasing the tester's competence also reduce random errors. Systematic errors, in turn, are often predictable and therefore identifiable. A systematic error may be caused, for example, by a situation where a measurement tool has not been calibrated. In that case, it produces similar results in repeated measurements, but all of them are incorrect.
There are many causes of measurement errors. The measurement environment may cause errors due to factors such as noise or lighting. The measurement equipment may be incorrectly calibrated or have another defect affecting results. The measurement method may be chosen incorrectly for the person being measured. Both the tester and the client can cause errors, for example, due to insufficient skills or lack of communication abilities.
It is useful to examine a measurement tool's usability and functional capacity assessment from both the client's and the tester's perspectives. From the client's perspective, it should be considered whether the instrument is acceptable, suitable, and available, how much time it requires, whether it is available in the client's native language, and whether it is culturally independent. From the tester's perspective, one considers what competence is required to use the measurement, what equipment is needed, how the results are interpreted, and whether reliable reference values are available for the tool.
Thank you for your attention. This video was produced as part of the Move On project and is co-funded by the EU.